How about others? In the late, Sandeep, other guys are missing or what? Hello, Sandeep. What about other guys? Okay, okay, fine. Let's continue then. Okay, before starting, any questions for the last class, especially the creating a load balancer and attaching to 3 different servers as an application load balancer and creating a target groups. Any questions on those guys? Please let me know if you have any questions. We'll talk it. We'll talk about it. So let's get started here. Please ping me if you have any questions. Okay, let me share my questions here. Okay. Okay, right. Thank you. No, sure. Thank you, Sharanya. Okay, that's fine then. Okay, let's get started here. Okay, today we are going to talk about is one of the last component of the AWS that is related to the VPC, and this is we are going to discuss it today itself. Okay, and especially in the VPC, we are going to talk about the subnets which are private and public, and these are all mainly useful for the um, creating the virtual network basically in AWS cloud environment. Okay, and in the last class we have talked about the EC2 IAM. Sorry, yeah, sorry, sorry guys. I think we have to talk about the IAM also. I think that will take another session also because this is also an important. We have talked about the EC2 volume security groups, load balancers, and target groups, right? There are 2 things pending, which we are going to discuss it one today. That is a VPC and another one IAM. Okay, let's get started here. Okay, as you know, right? So first of all, you log into your AWS account. This is where you can find, um, basically your EC2, VPC and the network related stuff. Here, there are 2 ways of that you log in. You just search with the VPC, which is stands for the virtual private cloud, which is especially the virtual private network that you would be going to create, which is exactly similarly like physically you are going to create a virtual network, right? For example, if you are working in any of the manufacturing company or some other company, right, they'll have their own network plan. Okay, their own network topologies. Similarly, you can also create those topologies, but not physically, but it's a virtually. And simply, they are calling it as a virtual private cloud. And in the virtual private cloud, there are some things I will just talk about them. First, you navigate to your VPC by searching the VPC under the search box. Otherwise, it will come under the network related services. This is where you would be finding the VPC also here. Okay. One more thing is each VPC, like other services in AWS, it will be different from each region also. Okay. Currently, we are in the Oregon region. In this region, this is the dashboard of like currently I do have one VPC, 4 subnets, one routing table, one internet gateway, one ingress rules. Okay, and 0 elastic IPs, 0 endpoints, 0 endpoint services. So we do have different things. I mean, this is a dashboard related to the VPC where you can find subcomponents of the VPCs also. These are all the subcomponents, okay, especially VPC, subnets, route tables, internet gateway, egress, elastic IPs, endpoints, NAT, okay, peer connections. These are all the subcomponents of VPC, and these are the utilizations of the VPCs, especially the NACL. It's updated. No, 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 no. I was joined from another device. But let's continue. We were been talking, right? And here, meanwhile, I'll talk about the theoretical part. My system also will be back in a minute. Okay. Oh my God. This is looks like the bigger one. Looks like my system is not going to come up in a minute, but let's wait for one more minute, guys. I mean, we'll talk while sharing my screen because that is going to happen. Okay, I'm back to the state now. Now let me. Okay, right. I'm back to my screen. Okay, guys, let me share my screen. Okay. Okay, guys. Okay. What we have been talking about is the VPCs. These are the subcomponents of the VPC, and these are the utilization layers of the VPC. Meaning, you would apply these security groups and NACLs to the VPC. Of course, we don't apply the security groups on a VPC, but internally these will be applied to the ACL, and from ACL we will apply on the VPCs. Okay, another one is DNS sets, the network firewalls, VPN related. Right? If you want to set up the VPN for your organization, right, you would be using these services, which is under the VPC part of it. Okay, and remaining we don't use. Mainly, we would be using and we would be focusing on the subcomponents of VPC and subcomponents and the NACL. That's it. We won't be utilizing other parts because these are all the deep networking related stuff we don't require. Okay, now let's talk about the VPC. What exact? I hope you guys are able to see my screen, right? Can someone please confirm me? I'm currently sharing my web browser, and right. Okay, thank you. Okay, so now basically what we'll be doing is we will draw a diagram. Right, even if you attend any interview question or even if you are working in any project, right, first they will ask you or they will share you, the documentation of your project, and the documentation will have a multiple documents along with the architecture diagram of the entire software. In the architecture diagram, mostly if it is working, I mean, if it is a dependency on the AWS, right, what will happen is, in the AWS, what they do is they'll draw a network diagram. Basically, not only the network diagram, the entire architecture they will be doing a network diagram. We will also, because that is an important to understand, we will also review a couple of network or AWS architecture diagrams from an open source related projects. Then we'll try to understand. Okay, so basically VPC is like exactly for the private network utilization, meaning uh, like we have a router. When we have a router in our home or in our office, we would be connecting to our routers, right? At the same time, everyone will, or every home or every organization will have their own network, I mean home router, right? Oh, just think about it. Why do we need a router? What they can do is they put us, for example, you are an ISP provider of Airtel or Geo, or I mean, you are an ISP receiver from an Airtel or Zio, or you know, any of ISP providers, right? Why they are giving you individual routers, or not only giving, why they are suggesting you to have a router in place in your home network or in your organization? Why can't put a router for the entire street, or one router for 10 in 10 houses, something like that? Why can't they put something like that? You just think about it, because they don't put, because if it is something like that, right, you won't have your own privacy. That is the main reason to don't have a common router between a combination of 10 houses, or a combination of 10 organizations, because especially the private, everyone will work individually and they want their own privacy terms and conditions. In the similar manner, in AWS, they want to isolate their own AWS services from a outer world. Outer world means a public world. That's why they want to create entire their services into the private network for their own safety and their own privacy concerns, especially, right? So whatever the resources they do create, either it could be EC2 or S3, or streaming related services, Lambda, or whatever you take among these 250 services, right? Everything will be under the AWS private network itself. And one more thing is, on top of that, what they do is they will be creating a, they are providing the, I mean, they are not only following their private cloud. Of course, they are also providing you the private cloud as a service also. I mean, not private cloud, I mean private network as a service also. That is nothing but the VPC here. Main thing is, the main concern is especially accessing their network securely. And one more thing is they are providing you the subnets also. I mean, basically you can't able to handle let me tell you on a problem. If you directly approach to solve any problem, it won't be solvable. What you have to do is you have to chunk it, meaning you have to divide the problem into multiple statements, and then you'll able to resolve some issues, right? Easily. In the same formula kind of an apply, in a VPC you have to create a multiple sub, I mean, there are chunks. That chunks is nothing but a subnet, and subnet is nothing but, I mean, they have divided the subnet in a two ways: private subnet and public subnet. What does it mean is, when you create any of the private VPC, for example, this is a VPC which you have created. uh, just think about it. Okay, what you need to do is, if you see any of the box in AWS diagram, there would be something right like VPC like this, meaning whatever the resources they are going to create, right, everything is under the within VPC, something like this. Okay, so something like this, whatever the resources. Okay, these resources are like within the VPC. Once they have done the VPC, they are going to create the a network into two parts, or a multiple parts. Those parts is nothing but a subnets. Okay, they can create a three subnets, or two subnets, or five subnets, or any of the subnets here. But the thing is, they can create two types of only subnets. Those are the private or public subnets. Okay, they can't create a third type of a subnet other than the private or public subnet. What these are subnets means, these subnets is a small part of a network. For example, you have a 20 or 36 of IPs. Just a minute, guys. You have a 50 or 60 IPs or 70 IPs or any how many IPs. These IPs are going to divide into two parts. For example, if you create a three subnets, these 60 will be divided into 20 subnets. I mean, I'm just telling you an example, but it is not an actual. We will be seeing those kind of a divide in the IPs with the using CIDR block. We will talk about it now. Just a minute. First, let me create this VPC here. Okay, now what I'm gonna do is I'm gonna create this VPC node under the here. What I do is I'll go. I mean, this is a VPCs which I do have in currently. I mean, this is a diagrammatic, so we don't want to touch this. What I want is let me go to the Oregon region, and there here I do have a subnets here. Okay, so VPCs. Create a VPC. I do want only one VPC here, and my VPC is nothing but a let me give something called RAT VPC 1. Okay, and this is go with the IPv4 only. I don't want any other things. Let's go with the default settings here. Your VPC name is RAT VPC1 here, and RAT is nothing but I have given a random name because which the one which I was working previously, and IPv4, and this is a CIDR, what does it happen is it will tell you if you don't give a CIDR, which is nothing but the IP addresses that you want to be give. I mean, the IP address range or the IP address naming. I mean, the IP address ranges that you want to be follow for this particular VPC. I want totally of this IP addresses. If you want IP addresses in the range of 172.0 dot something like private network, right? You can give, but the default one is 10.10.0.10. This is the IP range we would be giving for the private network mostly. Even if you open your virtual box and select for a NAT or a host only adapter as a VM adapter, right? What will happen is it will just show you, I mean, it will just give you the allocate the IP address in the 10 dot series because for the private network. Okay, don't select any of other things. If you select this one, right, these CIDR blocks will be allocated automatically. Okay, so just on. Hello, yeah, I'm back. So don't select any of other default ones. So create the VPCs only. So once you got created this VPC and don't, I mean, there is no subnets at all because we did not created any subnets for this VPC. That's why it is showing. And one more thing is the route table. We will talk about these also here. First, let me put it this way here. 1 minute, guys. So first what you do is you will be creating one VPC. Under the VPC, you are going to create a subnets. Those subnets are this is a VPC, RAT VPC1, and under this RAT VPC, we are going to create a subnet of a private, and this is another one. This is a subnet of public, and what we do is once we created it here, we would be creating another thing called a routing table, which has been responsible for distributing, you know, the request between the tables from an external world. What does it mean is, for example, you are here and you want to communicate something with this particular public network. I mean, one of the resources under here. I mean, meaning you have launched one EC2 instance here under the public network, and there is an EC2 instance in the private network. And you want to communicate from your home, meaning your uh, public network to I mean, from your home or public network to one of the services within this public subnet, which is nothing but your web application. What means you can't able to do the things like directly. What you need to do is you have to create one more service called internet gateway. With the internet gateway, then only you can able to internet gateway only you can able to with the internet gateway you can able to connect, and this internet gateway will be connected to the routing table here. So what we have just done is we just created a public sorry, a VPC. We just created. Now what we are going to do is we are going to create a two subnets. One is a private and another one is a public. After that we will be creating a one internet sorry NAT routing table here. And the route after routing table, what we do is we will be attach this routing table to these two networks. And after these two networks we will be creating a one more internet gateway. We will attach this routing table to internet gateway. Then our one-off instance related to the public subnets will be available to outer world. I mean, to the outer world. So whoever want to reach something, some resources which are under the public subnet will be able to access easily with the help of this setup. Okay. In a real time, this is a terminology. Let me tell you the use case here. Okay. Um, there is a web application here, meaning, and this is a client, this is a server. Okay. This is a client and this is a server. Okay. Now the communications will happen between these two like this. And at the same time, the request and the response also will be coming into the similar way. Okay. So meaning, for example, you open a browser is nothing but a client. You are accessing the google.com or facebook.com, meaning you are approaching a request to the server, right? What will, I mean, I'm just telling you a small example here. And now this server is nothing but a web server. Okay. This is a typical architecture diagram of any web application. Okay. Yeah, this is a web server. For example, it could be Apache or Tomcat or Jetty or Netty server. Okay. So each web server will have a database also connected here, right? And just think about this is your database here. Okay. And your database doesn't require need to be exposed to the outer world, meaning this could be a private. Okay. This could be a public. This is how your access rules should be. You should be applying in your architecture diagram. This is a simple two-tier architecture, not even two-tier architecture, a simple web application required. And your website will have a connection with your database and as well as a web server, each one. Okay. So you required only the connection. I mean, you required your web server to be a public and you require this, your database could be private. Why? Because this should have an access to only to the web server, not nothing else. How do they do it? There is something called, if you remember, there is something called network adapters. Okay, this web server have a two network adapters. One is private network I mean, one is a virtual network. I mean, of course, both are virtual networks adapters only. One is for the public, another one is the private. With the public network interface, meaning it will have a public IP address associated, which will be able to access by the public guys. That could be a client. There is another virtual adapter. This should be a public private one, meaning it will have a private IP addresses. For example, the public IP address could be 5.32 or something like this. Okay. 23 dot, it could be anything. Okay, in the private IP addresses, it could be 10 dot series or 172 dot series, 180 dot series, anything. Okay, so with the public IP address, they can able to access, meaning they can able to access publicly. And with the private IP address, since our database server is also in the private network, and it is having a private series like 172.9.0.12, right? This is a private IP address of a database server. And our another network interface of a web server also having a similar range of IP address. For example, 172.9.0.14. Okay, since these are in the same private network, because of this virtual private adapter, I mean, this is a network adapter, simply we'll call as a virtual network adapter, and it is having a private IP address, which both are in sync. This is where two web server and database server able to communicate, but database server doesn't is not able to communicate with the public guys. Okay, only internet. So this is nothing but a how our AWS will be. This is a one private one AWS VP. Under the VPC, what they do is they will be creating one VPC. They will be creating a one subnet called one subnet called private. This should be public actually, and this is another subnet called subnet of private. So this way, these two are being created here. Okay, once you applied this only one VPC and two subnets, it can't able to communicate. What you need to do is you need to create a route table in between. Let me do arrange here. I think we can't able to do the stuff. I mean, these things won't be required here. Just a minute, guys. Here is my tool here. So you would be creating a one routing table here, and then you will attach the one internet gateway. This way, it can able to access this thing. Now let's do hands-on for the same thing. We just created a one VPC. This is the VPC, RAT VPC1. Now next thing is we are going to create a two subnets and then use that for, okay, first I need to select our VPC, and this is the IP range of it. And my subnet name is, first let me create a rat pub subnet 1, and you have to select at least one or two one availability zone for this. You can select any of the things, but the thing is, for example, For example, you have to select the availability zone US West only, meaning if you let me show you here. In this one, US West 2, there are multiple availability zones here. Whatever the resources under West 2, I mean US West 2, which is nothing but Oregon region, right? These are the, for example, you have created a 5 EC2 instance here, and in Ohio region, you have created another 2 EC2 instances. You can't use the resources under Ohio region to Oregon VPC network, meaning you can utilize the resources under the Oregon region only, not anything else also here. Okay, so that is one thing. Another one is under the availability zone. Under the US East 2, there are multiple availability zones, which is for the disaster recovery, at least for the AWS side. So first you have to select either of the thing, US West. I mean, any of the thing is fine. Yeah, okay. And the IP range should be, this is your CIDR block, right? The first two digits will be common, 10.0.0. And for the public network, right, I'm going to give 10.1.0 here, slash 16 here, or 24 I would be giving here. This is an IP range of network here. Now let me create the subnets here, and then it has been created here. Okay, now let's me create this is the one, and this is the VPC. And here, what I could do is another one thing is called rad private subnet 2. I mean, subnet 2 here, and availability zone should be USDC, and 10.0 dot. These two are the fixed one here, here. And then my private subnet should be starting with 2 dot series. Earlier one is a 1 dot series. First two is been common here. And now this is my private CIDR blocks for my private subnet, which you are basically what you are giving is you are giving an IP address to your subnets. You are telling, hey, whatever the resources which are you are going to associate this subnet, please allocate the IP address of this range. Okay, so this is how it has been going to create. Totally, you got created a subnets here. Okay, and this subnets or these are the two things which we have just created here. If you see here, this is an IP address range, and these are the some of the other IP address range which is allocated defaultly here. Okay, in this one there are totally 251 IP addresses you can allocate to your subnets here. Okay, now next thing is we have just created a public subnets and private subnets here. And now what you need to do is you have to create a route table. Let's create that here. Okay, if you see here, there is a something called a route table here. By default it will be associated with the route table. Okay, now first let's create this route table. I mean, this route table and this internet gateway. Then we will establish a connection between these two. Then we will establish a connection between these two things now. Okay, either of the things we can do now. Now let's go to the route table. Route table is basically the main purpose of the route table is for routing a traffic between the two subnets or between the different subnets. Okay, so and this will also acts like a NAT also here. Okay, now whenever you create a VPC, by default automatically one route table will be get created here. Okay, and if you see here, there is a subnets. Let's see how many subnets has been associated with this. There is no subnets are associated for this routing table here. So what you need to do is, I mean, these are the possible subnets that you can attach to this subnet, this route table here. Okay, now what you can do is either you go to the Either you go to the subnets list and then select your subnet and then go to the route table and then edit this and then attach your route table here. This is one way of doing it. Another way of doing it, go to your route tables and select your route table here. The route table name you can give here something like or else what you can do is you can create another route table also. Let me show you because we have done here. Okay, route table and the VPC is this, which I'm going to select and then create a route table here. Now route table got created here. Now let's go back here and the third route table is this is the one we have created. Select this route table and select on the subnets that you want to attach. Now what you can do is you can edit these subnets here. Select these two subnets and attach to this subnets here, meaning your route table has a two subnets in it. Okay, so let's check this. If you see here, your route table has attached to this VPC and this is the route table ID and there are two subnets are associated. What are those subnets? These are the stuff. Okay, so one is a private subnet 1 and public subnet 2. I mean, these are the two subnets which we have associated to this routing table here. Okay, now we have associated this. Now let's go to the internet gateway here. And currently there is a one internet gateway is attached here. And then let's create another internet gateway. RAD IG 01. This is my internet gateway. We just created this one internet gateway. And then create internet gateway here. And you just attach part of it here. Okay. Attach this internet gateway to a VPC. Now select this one on the RAD and attach this one. Now this part has been done here. Okay. So whatever the internet gateway coming to, whatever the request is coming to your VPC through internet gateway will be coming with this connection, whatever we just attach now. So what we have done is we just select this and then see which VPC it is being attached to here. Okay, so this is the VPC which this internet gateway has been attached to. So meaning this entire VPC can be publicly accessible with this internet gateway. Okay, now what you can do is you can, another part of it is ingress only internet gateway, meaning what you can do is you can restrict the VPC connections. Basically it is not a good idea to expose your entire VPC resources to the internet gateway. Exposed to the external world through internet gateway. What you need to do is you have to create some firewall and network rules for that in order to save your access, save your AWS resources. Okay, here and then select this. This is an internet gateway here, and what you can do is you can attach this to your internet gateway and the route tables also. I'll show you. I'll show you the connection of this in one of the use case. I'll just show you. So main thing is elastic IPs also we have to find out here. In this region, there is no IP addresses, no elastic IP addresses are there. Meaning, if you create any of the EC2 instance, right? This EC2 instances will have a one public IP address, one private IP address, meaning this public IP address will be get changed on every restart. If you don't want get your if you don't want get IP to be changed, you have to assign some elastic IP address. Elastic IP address is nothing but they'll allocate you one IP address which are permanently for you until you release that particular IP address. That will be chargeable only. Okay, so what you need to do is you can create a one elastic IP. It will randomly allocate some IP address for you, so you can attach this IP address to your AWS resources of EC2 or ECS or API gateway. So anything you can attach this allocate IP address here. Okay, and another important thing is network ACLs. Guys, before doing this, another security part of it, uh, do you guys have any questions on this? Because this kind of a simple diagram required you need to be understand before going to explain some of the complex network architecture diagram of a AWS here. Okay, this is a simple. There is a one VPC. Among that VPC, there are two subnets. One is a private subnet. We have defined. Another is a public network, public subnet that we have defined. In order to access the resources which are inside of this public network, what we need to do is we have to create a route table and then attach this subnets to this route table, and then next we have to create an internet gateway, then attach these to internet gateway and sub routing table to both the things with the attaching to it into a VPC. So this is a common intermediary pointer between the internet gateway and the routing table. This way all are communicated in a single point. Okay, so this is a simple thing. Yeah, please let me know if you have any questions, guys. Is it clear? Siranya, Chandra, Tejaswi, can you please guys confirm me on this? Because this is you would be understanding, you would be getting a lot of issues while you are doing a practical part of it. Okay, now this is fine. Okay, thanks, Chandra. Now let's go for this one. This is the one thing is called a NACL. Basically, what does it mean is, whatever we have just talked about this VPC, right? This is exposed to the internet gate, public network through internet gateway, right? So lot of bad actors will be coming into your way. Meaning, what does it mean is, basically lot of people coming to try to access your resources from a AWS, which are in the AWS from an outer side one, especially the hackers. For example, you launched a website and they want to try to scan your application and then find some of the APIs have a vulnerabilities and they want to access it, right? What they can do is they'll scan out of it. How do they scan? They will, of course they would be scanning using a nmap, but the point is, yours whenever they do scan that particular resource in AWS, we shouldn't expose information as much as possible. Meaning, when do they scan, right? I have shown you one image. If they use an nmap, they'll get to know how many services are, how many ports are opening, what are the services, what is the version name, what server name, what is the service names. They'll get all the information about it. Similarly, in your VPC also, they'll get the information out of it. So to avoid such kind of information, there is something called network ACLs. Okay, you would be applying the secure. There are two things here: security groups, which we have learned while we are learning about the EC2 here. Okay, you would be applying the security groups at the EC2 instances. You would be applying the security groups and NACLs are the similar ones, but in a different manners. Security groups you would be applying at the EC2 instances. Network NACLs you would be applying for the VPCs, not for the EC2 instances. One more is, this is a stateless and this is a stateful. Okay, what does it mean is stateless and stateful. There are two terminologies. Stateful means it have a capability of storing something, storing some information. That is called a stateful. There is something called stateless, meaning it can't hold the a state. State means the information. Okay, there are two things here. So security groups and NACL. These are the stateful and stateless here. So this is a stateful. Network NACL is a stateful here. So I'm gonna create RAT NACL one for the public subnet one here. Okay, and the VPC which I want to apply this NACL is this RAT VPC one. Okay, I don't have any tags in it. So if you might have wondered what exactly you would be feeling about the tags here. You might have wondered this tags appears for every resources. What does it mean is especially this would be helpful when you have a complex resources in order to ask. For example, you can give a don't do anything about it here. I'm canceling it. I want to use it as it is. I'm gonna create RAD NACL for the public subnet one, and VPC which I want to use is for this, and I'm gonna add one more tag is called server type, and the value is access type. And the value here is that this is the public subnets mean. So whenever I just type or whenever I search something based on this particular keyword or a key value, I mean, this is a key name, this is a key value. If I type something in the entire AWS search engine with this one, I'll able to get the result easily if I don't remember any particular name or VPC IDs. This is like for tracking purpose that you can use tags. Okay, this would help you to identify quickly with the tag names. Okay, now let me create the NACL here. So I just created here. Here also like inbound outbound rules, right? Like security groups also have some inbound outbound rules here. So the major thing that you need to understand here is that there is something called state, meaning stateful, meaning it will remember each and everything. When you define any of the rules, either inbound or outbound, rules is nothing but you have to mention the type of protocol that you want to allow, the type of port, which port you want to allow, and which kind of a source IP that you are going to do that. Either you are going to deny it or accept it, you would be finding here. I'll just show you here. There are a couple of things here. Rule number. This is very important. I'll be just talking a minute. Okay. Here, let me put it this way. AWS NACL. Here, see this. These are the sum of the IP address they are doing alone. Now let me open another one here. Yeah, this is one which I'm talking about here. So these are the, if you remember here, there are rule numbers here. Okay. The rule numbers is nothing but the priority. For example, if we have a numbers like 1, 2, 3, 4, who is the first priority? The number 1, right? Similarly, the rules also that you would be applying on the for these rules here. Okay. For example, if request is comes to your services which is under the VPC, first what it will do is it will go to your inbound rules and then validate first rule, since you have given a rule number as 1. If all ICMP requesters coming to this one, please allow. It will go for the next rule. Okay. If the rule number is 100, Why can't go to the 500 or 400 or 300? Because the rule number you have given as 100, which is very less, which is very more priority than other four rules here. Okay, and then it will go to this one, this particular firewall, I mean this particular rule. It is saying that, okay, if the request is TCP, and if the request is trying to access between 1024 to 65,000 port, meaning in between of, if it is requesting for in between any of these ports, allow of any destination, use this. So it will go for the next rule until it satisfy or until it will deny. It will navigate through everything. Okay, if it is stopped here, right, it won't go for the next any of the rules here. Okay, meaning, for example, it is satisfied here. Now it will go for the next rule, which is number 200 rule. And if the request is a HTTP request of TCP type protocol, and if it is accessing for the port 80, it will go for this. If the request is HTTP, but it is requesting for 9,000 port, it will deny, because you did not specifically, you did not mention any of the port of HTTP type of 9,000. So it will deny the rule here, meaning whoever is trying to access the, or trying to scan the port of 9,000 port with this rule set of VPC, I mean NACL, they can't able to access, because they are allowing the HTTP protocols of 80 and HTTPS 443, and no other HTTP ports are allowed here. Okay, so this is how they would be doing it. I mean, this is how they would be securely configure their VPCs here. Now let's create the same thing here. Now this is the inbound rules, and I'm going to edit this. By default, start by rule number. I mean, they'll have something like this. Okay, rule number is 100. They have given something, right? First, I want to apply rule number 5. From 5 to 10, I'll be giving us some rule numbers here. And all traffic, allow this. Okay, now I'll add another rule called 6. First, whatever the request comes to my VPC, first it will validate the rule number 5, because this is the prior than the 6. And all traffic, if the traffic is requesting IDP, I mean ICMP type, or HTTP or TCP, or any type of request is coming, because I have mentioned all traffic here. If I mention only custom TCP, it will validate a lot of stuff here. So I just mentioned here. So please allow all traffic of all the resources, meaning no IP blocking or no IP whitelisting. If I want, what I can do is I can mention only my IP address, so it will accept only the request come from this IP address here. So I don't want this now. I want everything to be allowed now for just allowing access. And rule number 6, custom TP is 9,000 port, and I want IP address to be accessed by only this guy. Okay, this, if the request is coming from this IP address of this port, of which is a type of TCP, it will allow it. Otherwise, it will deny it. Now let me add another rule. I can give 100 rule. Okay, and I want this to be SSH, and by default SSH port will be TCP, protocol type is TCP, and port range is 22, and the IP address is anything, so it will be able to access. For example, if I want to restrict the SSH service between only for my IP address, let me do that. What is my IP? Okay, this is my IP address here. Okay, it is showing, yeah, this is my IP address. So if I add SSH connection only to this IP address, meaning SSH connections will be acceptable only from this IP address. So I want to allow this. Okay. Now I'm going to add another rule. You can be any, I mean, you can give any number, but the priority rule number is a major difference. First, It will go through each and every request through entire phase of all the stuff here. Okay, and this should be IPv4, and meaning sometimes, as I mentioned you, right, they will be scanning your reports or they will be pinging you. For example, if we want to test any SSH connection access is fine or not, right, what we should do is we will be ping it, right, ping and then find whether the particular particular server is reachable or not, right. Even we can block that kind of a request. For example, if you open your ping command, meaning if you open your command prompt and try to ping www.google.com, right? So you are getting a response from that. The request which is sending from my local machine to Google server is a ICMP protocol. It's a type of ICMP protocol. So Google server is accepting the ICMP protocol. For example, if they don't want to accept such kind of a ping request, right? What they can do is they can select echo reply destination unreachable. So they intentionally going to tell you destination is unreachable. So this kind of tricks they would be playing for their VPC server if they want to be private. Okay, they'll apply these kind of rules for everything here. Okay, destination protocol is unreachable, destination port is unreachable. So they can provide custom message information by using this kind of a settings here. Okay, and this also will help you to get a, I mean, to get rid of denial of service, DOS attacks, DDoS, I mean, attacks, right? Which is for the distribution denial service attacks, which is nothing but a, right? Hackers will keep on pinging your web server. For example, if your web server is, as we mentioned here, right? If your web server is a Tomcat server that is capable of handling 2,500 requests per minute. If more than that 2,500, your web server can't able to server or can't able to help any of the or manage any of the request at all, it will goes down. So like this, hackers would be writing some kind of a shell script to initiate the DOS attacks from a different servers, right? So meaning, right, what they do is they will be utilizing some of your, some of the hijacked servers and then pretend to be those are their own servers and then try to ping for your server. So ultimately, your server can't able to handle such many requests in a minute. So ultimately, it will goes down. To avoid such kind of DOS attacks, they would be disabling the ICMP rule here. Okay, so this way they would be saving or they would be secure their own network here. These are the some of the rules. See, it is clearly validating it. The IP address also. The source needs to be IPv4 or IPv6 block here. Meaning they are saying whatever the IP address that we have given here, 1.4/16, and this is meaning since it is a private, VPC, you have to keep the IP addresses within that PVC zone. Two dot. If you remember, these IP addresses we have given for our subnets, if you remember. Okay. Now this is the rules we have added here for the inbound of NACL. So what does it do is your VPC can able to validate only of these ports, of these protocols, of these HTTP types here. And if any other request other than whatever you mentioned, it will be denied. This is the meaning of this. This is very important. This is called a stateful, meaning this stateful means it will hold the entire information about it, previous state, this state, and everything, because it has to navigate through all the rules, whatever it is been mentioned here. Okay, let me put it this way. Stateful or stateless here. So you're defining all the information and the parts of here. Security groups is been this, and then you would be applying the NACL on top of this, meaning you would be using a security group for the instance level. You would be applying the NACLs on the network level, which is on the subnets or VPCs here. Okay, this is the information. 1 minute, guys. 1 minute, guys. Okay, guys, back. Um, So ultimately, this is the main important part, and we don't require other parts because these are the deep concepts of a network related. As a part of our course curriculum as a DevOps engineer, right? We would be required to know our VPCs, routing tables, subnets, uh, NACS, which is very important part. Yeah, this is mainly about the VPC, what we have learned other than private and public subnets. Those are the routing tables, subnets, elastic IPs here. And one more thing is sometimes you require to know this also. These are the endpoints of the VPCs, meaning VPC1. This is a if someone want to assign your IP addresses, I mean your VPC, what they do is they will create this endpoint, and then they would be providing an endpoint to the external guys. So that's how they would be using your VPC to your what must be at least one load balancer. I don't have any one load balancer for this. Let me create this. Oh, yeah, I do have a load balancer for the another reason. That's why it is showing me the another thing. I want to be network load balancer. Of course, everything it will ask us to do the stuff. RAD VPC LB here. This is an internet facing. If we want to be private, we have to give a internal. Okay. Currently, I do want a internet. That's why I have given here. Under the VPC, we need to select the respective VPC here. And I'm going to select these two availability zones. Okay. This does not have it is saying. This is also does not have something. Yeah. So it is, there is a proper strategy that we, I mean, not strategy, I could say there are proper steps. We have randomly used those, all the stuff, right? This guy is saying you have to apply some kind of a subnets or internet gateway, then you can apply this one. That is guy, this is saying. So instead of that, what we do is we'll create a load balancer of an application. Again, it will ask us to the running instances where we should be doing something like that. Okay. So this one, see, it is going to say, it is not going to ask. Again, the subnet that we are going to use may not have the proper one. That is why it is showing you. Again, we should select the some target groups, everything we have to set up everything. Okay. We don't do it right away. But ultimately, what I want to tell you is, if we want to create an endpoint service, we have to complete the entire setup that is required a proper internet gateway, routing table, and other services here. Okay. So when do we use this endpoint is, especially if someone want to use VPC through API access, right? You would be using this endpoint services. Once you created a endpoint services, you would be getting one ID. You would be providing that endpoint, API to other services. They will start using it. Okay. Yeah, guys. This is it about for today, and especially the VPC part. These are the important concepts we have to know when we mention VPC in our resume here. Okay, I'm gonna delete of all this because this is going to be charged for me after some time. Okay, any questions, guys? Chandra, Tejashwi, I know you guys are only left. Any questions? Of course, what we do is you would be getting mm, questions for sure when you do a practice for sure, because um, we would be facing an issue, especially while creating a public and private subnets and assigning a IPs to them. That is the place where you would be get confused. Please don't hesitate to reach out me if you have any questions for the next class also. Okay, that's it, guys. Thank you very much for today. Let's continue for tomorrow related to the IAM. Okay, thank you.